Just a few reminders before you begin this quiz. First of all, what does it mean for a sequence to converge? And perhaps Sal Khan referred to this in his videos. But for a sequence to converge, well, it means exactly what it says, that if you have some sequence, right, a sub n equals, I don't know, 1 over n, that, or sometimes written like this, 1 over n, and n goes from 1 to infinity. What it means is that as n gets bigger and bigger and bigger, this is going to get closer to some number. In other words, that the limit as n approaches infinity, right, as n gets bigger, exists, right? It's going to be something. So certainly if I asked you, does this converge? Well, that's so easy. You know the limit as n approaches infinity of 1 over n is going to be 0. That's one of the main concepts of calculus, really. But I also want to talk about some other sequences. Let's talk about geometric. And you know what a geometric is. You've been doing this for years. A geometric is something that is multiplied. The coronavirus right now is multiplying, it seems to me, by a factor of 2 every 3 days. Really scary. But if you have a geometric sequence, something that looks like this, and we look for the limit as n approaches infinity of, let's say, 32 times 1/2 to the n minus 1. Does this converge or not? Well, it certainly does, because we know that as n approaches infinity, this is going to go towards 0. 32 times 0 is just going to give us 0. However, if you have the limit as n approaches infinity of 32 times, let's say, 1.5 to the n minus 1, we've got a completely different story, because our r value here is greater than 1, right? So this is something you've known for a long time. A geometric series will converge if r is, the absolute value of r is less than 1. But if that absolute value of r is greater than 1, it's certainly going to diverge. And absolute value is something else we'll talk about at a certain point. Okay, and as far as arithmetic is concerned, and arithmetic is basically linear, right? So a sub n is going to be a sub 1 plus n minus 1 times d, you know, our common difference. So if you had something like a sub n equals 3 plus 4 times n minus 1, no matter what you do, this is going to be linear. And so this is going to diverge. But it's a completely different kettle of fish if we have a sequence, a series. And you know that a series is a sum. And let's just talk about, a geometric series. And this is something that Sal Khan did talk about. So if you have a geometric sum, that's going to be a sub 1 plus a sub 2 plus a sub 3 plus, right, all the way to a sub n. But a sub 2 is a sub 1, r to the n, or that's going to be r to the first, right? A sub 3 is a sub 1, r to the second, plus blah, 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 right? And you know that the sum as well, if this is geometric, the geometric sum, the geometric series will converge if the absolute value of r is less than 1. And it will diverge if the absolute value of r is greater than 1. And we'll have a lot to talk about whether series converge. In fact, that's the major topic of this unit. But the one rule that you know is a geometric series converges if the absolute value of r is less than 1.